Welcome to the Season 2 of About Creative Uses of AI in Norway. We are thrilled to announce the continuation of the Blender tutorial concerning the issues of character interaction in Blender. This will be the final tutorial for this clip. Now, let's go to my human counterpart to introduce what will happen.
I am your host, Ali Sobot.
Don't be a prick. Make sure to like, comment, and subscribe.
Today is 19th of March 2026. Hi guys, welcome to Season 2 Episode 10 of Creative Use of AI in Norway. First, like always, we're going to goof around neural networks and then start with the creative parts of this episode. Before that, let's make a recap of last episode. Last time we explored AI image comprehension, focusing on CNNs, convolutional neural networks, and autoencoders based on David Chapman's work. CNNs process images in layers, moving from simple edges to complex objects. Autoencoders act like secret code machines. An encoder compresses data in a latent space, the essence of the image, and a decoder rebuilds it. In Stable Diffusion, a good autoencoder ensures that noise transforms into sharp, recognizable features like eyes instead of blurry blobs. Okay, now over to this episode. We're now going to talk about generative models again, based on David Chapman's book. He states, internal state is achieved by allowing neurons to send feedback signals to other neurons. As a result, the output of a recurrent neural network is influenced not only by the current input to the network, but also by what has been learned from previous inputs. The maintenance of state allows RNNs to exhibit dynamic temporal behavior and make them particularly well suited for tasks that involve sequential data such as natural language processing time series, prediction, and generative models. The ability to remember previous inputs mean that the network takes into account the context of an input sequence, which is a crucial aspect in many real-world applications. So, FYI, there are two keywords here. Generative models and recurrent neural networks, or RNNs. I really didn't understand much of what he said there on the quote. Also, last time we talked about Stable Diffusion as an example of how an AI model not only sees an image, but also how it reproduces those images by memory. So the question is, are diffusion models that turn noise into images with the help of autoencoder generative models or not? So the answer is yes. But why? In order to answer this question, we need to know what a generative AI model is. Now, since I didn't understand what David Chapman was saying, sorry, I use now a support literature written by Willy Brandt in his book called Generative AI and LLMs for Dummies. And he argues, Gen AI is a type of artificial intelligence that uses neural networks and deep learning algorithms to identify patterns within existing data as a basis for generating original content. By learning patterns from large volumes of data, Gen AI algorithms synthesize knowledge to create original text, images, audio, video, and other forms of output. So, based on both of these codes, it is safe to assume that diffusion models, just like large language models, are generative AI models. So now, the reason I brought in Brandt's code here, because it clarified the point I wanted to make about generative models in general. Since I have worked a lot with image models, although mostly legacy models like Stable Diffusion's 1.5 and XL models, it was interesting for me to know how a theoretical foundation on what I actually was doing. We're doing, okay? So let's break down this a bit more, shall we? Like, how does this shit actually work? Because we know hopefully now that what we are talking about, but we hopefully know now what we are talking about, but we don't know how it works. I'm going to bring Gemini, my co-host, to answer our questions. I want you to welcome you back to the show, Gemini.
Thanks, Ali. Always a pleasure.
Okay, enough pleasantries. Let's jump right into it. I want you to explain to me about the importance and the know-how of how neurons send feedback signals to other neurons, resulting into a recurrent neural network, not only by the current input to the network, but also by what has been learned from previous inputs. You know, basically Chapman's code. Also make sure to point out what the point for this process is based on Chapman's code.
All right, let's get into the guts of it. To understand Chapman's point, you have to stop thinking of a neural network as a one-way street and start thinking of it as a loop. In a standard feed-forward network, like a basic image classifier, the data goes in, gets processed, and an answer comes out. It has the memory of a goldfish. Once that image is processed, it's gone. Recurrent neural networks, RNNs, change the game by introducing the feedback signal.
Okay, great, but now tell me on the, great, but now tell me how does this shit work?
I am going to explain this by dividing my answer into 3 levels: the feedback loops, the point of the loop, and finally, the internal state in the creative workflow.
Okay, go on. But make the answer simple, don't talk over my head.
The encoder, the squeezer. Imagine you have a giant high-quality photo. The encoder's job is to compress or squeeze that giant photo into a tiny secret code. Quote, it throws away all the boring stuff, like extra noise, and only keeps the most important parts, like the vibe of the cat.
Wait. Just watch this video and explain the process. I don't get the words you're using right now. And again, I can't emphasize this enough. Make it as simple as possible.
The know-how of a recurrent neural network, RNN, lies in its departure from the simple one-way flow of traditional networks. While a standard feed-forward architecture only moves information forward from input to output with no loops, an RNN is characterized by cyclical paths or connections that cycle back into themselves. quote.
So, based on what we have seen and what we have heard, what are the key points that we should take away from Chapman's quote?
So, the key takeaways from Chapman's quote are the following. RNNs use feedback signals. When neurons talk back to each other, this creates an internal state, acting as memory. Outputs are influenced by both current and past inputs. This enables dynamic temporal behavior, making them perfect for sequential data like text or time series. Crucially, this provides context, helping the AI understand a sequence as a whole, rather than just isolated bits.
Great. What are they and how do they work?
Sequential data is a story where the order of information matters. Neurons use feedback signals to talk back to themselves in a loop. This creates an internal state, which is like a memory backpack. Because it remembers the past, the AI shows dynamic temporal behavior. Its guesses change as the story unfolds. This allows the AI to understand the whole context instead of just one piece at a time.
So, if you now combine this with the concept of Gen AI, how would that work?
General AI combines these memory loops with creative architectures. GANs use a generator to create data from noise, while a discriminator judges it. RNNs use their internal state to ensure generated sequences stay coherent. Autoencoders compress data into a latent space and then decode it into new versions. This allows AI to learn deep patterns and produce realistic synthetic content.
Finally, a lot of thanks to Gemini and Clean AI for all the help with the questions and question and answer sessions and the visuals of this video. Now we are going to part 2. This time around we're going to complete the Blender tutorial we started from a couple of weeks ago. However, I will have a special edition from the Golden Shark Prize announcement where I will inform you who has won the best AI short film made in Norway as of the time of this recording. Now, as far as if it's only limited to Norwegian AI artists, I need to double check that with those who basically have set up this event. But as of now, I think it's AI short films that are made in Norway. As of the time of this recording, there has been 40 participants, and one of these participants is yours truly, with my short film or music video, if you will, which is also which is also one of the nominated short films. But my gut feeling is telling me that Edmund Yang is winning this year's prize as well, just like last time. That is for the next week, not now. So, have a blast with the tutorial. Thank you for subscribing to my channel. If you haven't, make sure to do that and hit that like and share button. See you on the flip side, or at least my AI version will do that. Cheers.
Make sure to like, comment and subscribe. Now let's jump right into part 2. When characters interact in Blender, they have a tendency to ignore rather than actually engage with one another. They're passive-aggressive like that. As a creator, it's your job to fix that. That's why I made this tutorial on Blender animation, to help you solve those character interaction issues once and for all. Blender animation, fix interaction issues between characters. So, how you ask? Let's go. So here goes. The repositioning of the characters. Choose the armature of ChatGPT character first. Press G plus X and move the mouse to place the character in front of the other character. Adjust the angle. Press G plus C and move the mouse to place the character in front of the other character. Adjust the angle. Press G plus X and move the mouse to place the character in front of the other character. Press Command plus A or Windows icon plus A, choose All Transform.
Langt i det fjerne bak månens slør finns ett rike av
WTF? Press Ctrl Z to undo.
Hvor stjernene danser i lystig syn. Ærlandet der en står forlatt, midt i en skog av sukkersvart. Bladene sang en hvesende lyd, bakken var dekket gullfarget myr.
WTF? Reopen the project without saving it. I undo transform all, cause if I don't, I hug up the animation. Now we will be repositioning with transform key. Find your position. Go on the transformer tablet board or whatever and push I on the keyboard. Voila! Your first animation created. Keep repeating the process to have everything right.
Mørk og verden stor, snubler de rundt uten kart eller spor. Men sammen i kaos de finner en niende, ler mens de roper
Let's render in Blender. Render and crop region to save rendering time. Choose where do you want to export your animation on TMP. Right mouse click, new folder, folder name. Choose render, then render animation. It took several minutes for me to render the image sequences. Here, I spared you the Blender engine work. Let's animate the sequences. Press File, New, Video Editing. Press Shift A, Image Sequence. Press A to select all the sequences. A to select all the sequences. Adjust timeline. To match the animations, change from 250 to 180, because the sequence here is 180 frames. Choose where do you want to export your animation on TMP. Create a new folder to organize everything. Great! Everything is now animated. Oh wow! Thank you for watching. I absolutely can't wait to hear all about where you're tuning in from in the comment section below. And of course, just because I'm Alice AI version doesn't mean your comments aren't wildly important.